Hey there, welcome back to Z-Tech Advisor. Today, I'm excited to share with you a fantastic traffic mirroring tutorial, so buckle up and let's get started. Traffic mirroring. When discussing the fortification of our enterprise infrastructure, it's paramount to delve into the concept of traffic mirroring. This practice serves as a cornerstone in our efforts to secure networks, allowing for thorough surveillance and analysis of network activities. At its core, traffic mirroring enables the monitoring of data flowing into and out of a network, facilitating comprehensive scrutiny of network traffic patterns. To execute traffic mirroring effectively, various methods are employed, including span ports, port mirroring, VPC, and network taps. The switch port analyzer port, commonly referred to as a span port, represents a method specific to Cisco devices, designated for port mirroring. Although in industry parlance, span ports and mirrored ports are often used interchangeably, technically, the term span port is applicable only within Cisco environments. However, for the sake of coherence within this course and examination, both terms will be used synonymously. Essentially, the configuration of a span port or mirrored port entails instructing the router or switch to duplicate every packet processed by the device, forwarding it to the span or mirrored port. This enables the connection of monitoring devices to capture and analyze all network packets traversing the specified segment. For instance, within a smaller network setup, implementing traffic mirroring on the external router facilitates comprehensive monitoring of inbound and outbound traffic. Various router brands offer distinct features concerning traffic mirroring, with support typically extending to 3 types: local, remote, and ACL-based traffic mirroring. Local traffic mirroring, the most rudimentary form, enables the connection of a monitoring device to a local port, receiving duplicated traffic for analysis. Conversely, remote traffic mirroring facilitates monitoring over a network via GRE tunnels, eliminating the need for direct cable connections to the monitored device. ACL-based traffic mirroring allows for traffic monitoring based on interface ACL configurations, offering granularity in selecting mirrored traffic based on predefined permit or deny statements. However, as technological landscapes evolve, particularly with the proliferation of cloud-based infrastructures, conventional methods like span ports and mirrored ports may prove inadequate. In such scenarios, traffic mirroring in the virtual private cloud, VPC, emerges as a viable solution. VPC-based traffic mirroring entails the replication of inbound and outbound traffic to network interfaces attached to cloud-based servers within a VPC. This mirrored traffic can subsequently be directed to a monitoring appliance within the same VPC or a different one, facilitated by inter-region peering or transit gateway connections. Configuration involves defining traffic mirror sessions and applying filter rules to select relevant traffic for encapsulation into VXLAN headers, destined for monitoring and analysis. Lastly, a distinct approach to capturing network data involves the utilization of network taps, physical hardware devices connected directly to the network. Equipped with multiple ports, including one dedicated to mirroring, network taps intercept data flowing between network segments, forwarding copies to monitoring devices in real time. The choice among these methodologies hinges on specific requirements and circumstances, with hardware taps often favored for permanent installations across all network devices. Conversely, span or mirror ports might suffice for ad hoc troubleshooting, while VPC-based solutions are imperative for cloud architecture monitoring. Each option presents unique advantages tailored to diverse operational needs and infrastructural configurations. Expanding further on the intricacies of traffic mirroring, it's crucial to understand its role in enhancing network security and operational visibility. Beyond the initial setup of span ports or mirrored ports, meticulous configuration is essential to optimize traffic capture and analysis. This includes defining filter rules based on specific criteria such as source or destination IP addresses, protocols, or port numbers. By fine-tuning these filter rules, organizations can focus monitoring efforts on relevant traffic, reducing noise and improving the efficiency of security investigations. Additionally, advanced features like packet truncation and timestamping may be employed to streamline the analysis process and provide more granular insights into network activities. These capabilities empower security teams to swiftly detect and respond to potential threats, bolstering overall cyber resilience. Moreover, the deployment of traffic mirroring solutions necessitates careful consideration of scalability and resource allocation. As network infrastructures expand and evolve, the capacity to handle increasing volumes of mirrored traffic becomes imperative. Organizations must assess their monitoring infrastructure's scalability, ensuring that it can accommodate growing traffic loads without compromising performance or accuracy. This may involve deploying distributed monitoring architectures or leveraging scalable cloud-based monitoring solutions capable of dynamically scaling resources based on demand. Additionally, proactive capacity planning and regular performance testing are essential to identify potential bottlenecks and optimize resource utilization, safeguarding against degradation in monitoring effectiveness during peak usage periods or traffic spikes. Furthermore, the integration of traffic mirroring with comprehensive network security frameworks is essential to maximize its effectiveness in threat detection and incident response. Traffic mirrored from network segments should be correlated with data from other security controls, such as intrusion detection systems, IDS, endpoint detection and response, EDR, solutions and security information and event management, SIEM, platforms. This correlation enhances contextual understanding of network events and anomalies, enabling security analysts to differentiate between legitimate traffic and potential security incidents effectively. Additionally, automated workflows and orchestration capabilities can streamline incident response processes by triggering predefined actions or alerts based on detected threats, reducing response times and mitigating potential impact. By aligning traffic mirroring with broader security strategies, organizations can establish a more cohesive and proactive approach to defending against evolving cyber threats and maintaining the integrity of their networks. Thank you for joining me in this exciting tutorial. I hope you found it helpful. Don't forget to like this video if you enjoyed it and subscribe for more awesome content like this one. Happy learning, folks!